Pumps are the heart of an irrigation system when you're not using pressurized city water. They provide the pressure and flow needed to get water from the source to your sprinklers. And if they're not working properly, nothing else will. Today we'll walk through the types of pumps you're likely to see, how they work, and what to look for when choosing or maintaining them. If you're using a water source that doesn't come pre-pressurized, like a well, pond, or canal, the pump becomes the heart of your irrigation system. It's what gives the system life. Without enough pressure and flow, even the best designed system won't perform the way it should. The pump needs to match the system, not just in size, but in capability. That means understanding the type of pump you're using, where it's placed, and what it's connected to. Choosing the wrong pump or running it without proper controls or maintenance can lead to poor performance, wasted energy, or even system failure. So before you dive into design or installation, make sure you've got a solid understanding of how pumps work and why they matter. You'll usually come across three main types of irrigation pumps. First, horizontal closed-coupled pumps. These are the most common and straightforward to install. Then there are submersible pumps, which operate completely underwater, often inside wells. And finally, vertical turbine pumps, which are typically used in larger, more demanding systems. Each one has its own strengths and installation requirements, so let's take a closer look at what makes them different. Let's start with the horizontal closed-coupled pump. This is the most commonly used type in irrigation systems. It gets its name because the pump and motor are directly connected, with no separate shaft or coupler in between. That setup makes them compact, efficient, and relatively easy to service. These pumps come in different configurations. Single stage for basic jobs like pulling water from a pond or lake, multi-stage when you need more pressure, like for hilly terrain or long pipe runs, and jet pumps, which use a little assist mechanism to help move water into the impeller, great for shallow wells or boosting a low-pressure system. Horizontal closed-coupled pumps are super versatile, and you'll see them in everything from residential landscapes to commercial installs. Single-stage pumps are great when you're drawing water from a surface source like a lake or canal, or using it as a booster pump to add pressure to a pressurized line. It uses one impeller, so it's efficient and reliable, just not ideal for high pressure needs or systems with elevation changes. Now, when you need more pressure, especially if the sprinklers are far away or higher than your water source, a multi-stage pump is your solution. It has multiple impellers, each one adding a little more pressure while keeping the flow steady. It's kind of like a team of mini pumps working together inside the same unit. You'll often see these on large commercial or steep residential sites. Jet pumps are often used in shallow wells. They use a mechanism to help lift the water before it enters the impeller. They're a nice middle ground when you need a little more boost but don't want the complexity of a multi-stage setup. You'll mostly see these in residential or light commercial systems. Submersible pumps are exactly what they sound like, pumps that live underwater, either in deep wells or inside a horizontal sleeve in a lake. These are multi-stage centrifugal pumps, and they're completely sealed, which makes them quiet and protected from the elements. They're common in rural homes or commercial sites where one pump may serve both the house and the irrigation system. Just keep in mind, they require power down at the source and can be costly to service if something goes wrong deep in the well. Last but not least, let's look at the vertical turbine pump. These are heavy-duty pumps used for larger irrigation systems. Think parks, golf courses, or agricultural operations. Unlike submersible pumps, the motor stays above ground and the pump end sits vertically down in the water. You'll usually find them mounted on a steel platform or skid, often with a control panel and electrical hookup right there on site. Sometimes they draw water from a flooded sump, which is basically a holding pit next to a pond that stays full, and that allows gravity to help keep the pump primed. Vertical turbine pumps can deliver high flow rates and pressure, but they need careful planning, electrical access, and usually a professional install. They're not something you just plug in and go, but for big jobs, they're a powerful and efficient option. No matter the type or size, most irrigation pumps have the same core parts, kind of like the anatomy of this system. Let's break it down. The drive, usually an electric motor, spins the drive shaft, which turns the impeller. The impeller is what creates pressure and flow. It spins the water outward. The water enters through the suction intake, floods the volute casing, and exits through the discharge pipe. The volute is the part that turns the water's spinning energy, its velocity, into usable pressure. The shape and size of the impeller and volute make a huge difference in how much water the pump can move and how far it can push it. So even though pumps can look different on the outside, the basic process is the same. Spin water fast enough to build pressure and send it where it needs to go. Let's look at it from a different angle here. Water enters through the suction intake, the impeller spins, increasing the water's speed. That velocity is turned into pressure inside the volute, and the water exits through the discharge line. This whole process depends on the pump being flooded. It can't pull water up, it can only push it. That's why proper insulation, water level, and pipe angles matter. Let's talk physics for a second. Pumps can't suck water up. They rely on atmospheric pressure to push water into the impeller. Think of it like spinning a bucket with holes in the bottom. The faster you spin, the more pressure pushes the water out. That's what the centrifugal force is doing inside your pump. And if you're at a higher elevation, there's less atmospheric pressure, so pumps are less effective. That's why system design has to factor in elevation, especially with surface sources or wells. For example, at sea level, the pressure from the Earth's atmosphere is 14.7 pounds per square inch psi, while in Denver, Colorado, at 5,280 feet or 1 mile above sea level, the atmosphere weighs 12 psi or 2.7 psi less than at sea level. Multi-stage pumps are kind of like a team of pumps working together. Each impeller adds a little more pressure to the water without changing the flow. Picture it like passing a basketball down a line of players. Each one gives it a push forward. Same flow, but with more force behind it at each stage. These pumps are ideal when you need high pressure, like when you've got a long distance between your water source and your sprinklers, or when your system has a lot of elevation gain. The key thing to remember is each impeller increases the pressure while keeping the same gallons per minute. So instead of one impeller doing all the work, it's spread out, and that's what makes multi-stage pumps efficient and powerful. Pumps don't just run whenever. They need controls to turn on and off at the right times. Some systems use a pressurized tank with a pressure switch. That setup maintains steady pressure and turns the pump on when pressure drops. These are great when you have hose bibs or quick couplers drawing water during the day. More advanced systems, especially those tied to an irrigation controller, use a pump start relay. This relay sends power to the pump only when the controller says so, like when a zone valve turns on. Just remember, if you try to open a valve manually out in the yard, the pump won't kick on unless you do it from the controller. Even the best pumps need a little attention from time to time. Here are some common issues to watch for. A worn impeller can't build pressure like it used to. You might notice weak spray or zones not running fully. Cavitation is when air gets into the pump. It sounds like a rattle or grinding, and it can destroy the impeller if left unchecked. It usually means your suction line isn't fully flooded or there's a leak pulling in air. If your pump is making strange noises, cycling on and off too often, or the system just isn't running like it used to, don't ignore it. Those are early warning signs. Regular maintenance, cleaning filters, checking seals, and keeping an eye on performance will go a long way in keeping your system running smoothly. And remember, if you're not sure, call a pump expert before things get worse. A little early troubleshooting can save you a lot of time and money down the road. All right, let's bring it all together. Pumps generate pressure and flow, which means they're critical to how your system performs. Choose the right pump for the job based on your water source, elevation, and system pressure needs. Understand the basics of how a pump works so you can spot problems early. And don't forget maintenance. Pumps will last a long time if they're sized right, installed properly, and kept in good shape. A well-designed pump setup can make the whole irrigation system run smoother, quieter, and more efficiently.